Good morning, students. So in last class we discussed about the mole concept. So in the last class we did it in sheets. So you may not see in the board, students. So in the last class I explained how to convert the mole, means mass into mole, mole into mass, volume into mole, mole into volume. Okay. Similarly, that number of particles into mole and mole into number of particles. Okay. So students, in the today's class we are going to study another one formula which is very important, that is percentage composition. Another one is the second formula, percentage composition. So what is this percentage composition? So percentage composition is equal to formula mass of the one element or mass of a one atom or a one molecule to the molecular mass of the compound. Mass of the one atom or molecule to the molecular mass of the compound into 100%. This is called percentage composition. So students, for example, A and B is the AB is the compound. Okay. Here, percentage composition of A is equal to what? The element A divided by mass of AB. Are you right? Mass of A divided by mass of AB. So percentage composition of B is equal to mass of B divided by mass of AB. So this is the formula. Okay. So based on this, we are going to calculate so many. Always we have to compare the percentage is equal to how much? 100. Okay. So students, we will discuss one by one the percentage composition of the each element. So first, that is NaOH. First you have to calculate how many atoms are there. Na is there, oxygen is there, hydrogen is there. Okay. So first you calculate molar mass of NaOH, that is equal to 1 into Na plus 1 into oxygen plus 1 into mass of hydrogen. Mass of sodium is 23, mass of oxygen is 16, and this mass of hydrogen is 1. So that is equal to 23 plus 16 plus 1, that is 40. Okay students, this is what? Molecular or molar mass of NaOH. Instead of molar mass, you take molecular mass. Okay, so then first one, percentage composition of sodium. What is the formula? Mass of the one atom to the molecular mass of the compound. Here we taken sodium means mass of sodium is 23 divided by mass of the compound is 40 into 100%. If you do 23 divided by 40 students, you will get 0.575, so that is 57.5%. We will calculate by using calculator. Okay, this is 23 divided by 40 into 100%. Similarly, percentage composition of oxygen. What is the mass of oxygen? 16. Mass of a compound is 40 into 100%. So you do 16 divided by 40. Then you get 40%. Okay, next. Percentage composition of hydrogen, that is 1 divided by 40. 1 into 100%. So you may calculate by using these students, or you may calculate this is 2.5%. Okay, so NaOH is there. So once you have Na, once you have oxygen, once you have hydrogen. So if you have only these two, you don't know this means you just do 100 minus sum of these two, 57.5 minus 40, you will get 2.5. That is what? Percentage composition of hydrogen. Okay, you may add, you may subtract. Understood, students? So if you add the composition of all three, so 57.5 plus 40 plus 2.5 is equal to 100%. Okay, so this is how to calculate the percentage composition of the atoms. So this is NaOH. Similarly, we will do it for another problem. Okay, you take CaCO3. Okay, so first you calculate molecular mass of CaCO3. So students, 1 into Ca plus 1 into carbon plus 3 into oxygen. The mass of calcium is 40, mass of carbon is 12, this mass of oxygen is 16. So that is 40 plus 12 plus 48, that is 100. Okay, students. Now, percentage composition of calcium. Okay, what it is percentage composition of calcium? So calcium is how many grams present in that? 40 gram divided by 100 into 100%. If you divide this, you will get 40%. Similarly, percentage composition of carbon. So carbon is 12 divided by 100 into 100. So these two gets cancelled, that is 12%. Okay. Similarly, oxygen is there. Percentage composition of oxygen. So oxygen is in how many grams? 48 grams. That is 48 divided by 100 into 100. So it will get cancelled, that is 48%. If you add all these, you get 100% students. Okay, this is the way to calculate the percentage composition of the respective atom. Okay, what happens here? First, we are going to calculate the molecular mass of the respective compound by adding the masses of the substances. Once we came to know the molecular mass, then the given mass of the element or the amount of the individual atom present in that compound to the overall mass of the compound multiplied by 100 gives the percentage of the respective atom present in the metal or a compound. Okay. So the next one is C6H12O6, that is glucose. So if you have to calculate the molecular mass, I will write directly 6 into 12 plus 12 into 1 plus 6 into 16. 6 into 12, that is 72. This is 12. This is 96. You will get 180. Okay, students. Next, from here, percentage composition of carbon. Percentage composition of carbon, and percentage of composition of carbon is equal to carbon present in how many gram? 72 gram divided by 180. Okay, so this will be into 100. So 72 divided by 120 means, 180 means that is 40%. Okay, next. So percentage of oxygen or a percentage of hydrogen you take, that is 12 divided by 180 into 100. So 12 divided by 180 means 6.66%. Okay, so students, you know these two, then you minus these values, then you will get the value of that oxygen. So for 100 minus 46.66, but we directly add these two, you get 100 minus 46.66, addition of these two, correct? Then 100 minus 46 means that is 54.4. 53.44. And if you want to calculate, student, so percentage of oxygen is equal to 96 divided by 180 into 100%. If you divide that 96 divided by 180, you will get 53.333. So that is also taken as 53.4. Okay. This one is 44. The value is 333, approximately 53.4. Okay. So this is how we are going to calculate the percentage composition of the individual element present in the compound. Okay. Similarly, you can do it for H2O, Na2CO3, whatever the values you want. You may do it for all things. I think this much is enough. I hope you understood. What do we have to do? So we have to first calculate the molecular mass of the complete compound by adding the atomic masses of them. So once we got the molecular mass, the respective mass present in that compound to the molecular mass ratio into 100 gives what? The percentage composition of the respective element in that term. In that compound. Okay, so this is all about the percentage composition. So students, this completes unit 1. So in the unit 1 you studied about what? In the unit 1 you studied about the percent volume of the substance, okay, matter, how it is classified. So matter is classified into physical classification is there, chemical classification is there, correct? So after that, physical and chemical classification, you came to know what are isotopes, isobars. Okay. So in that isotopes and isobars, again you came to know what is atomic mass, molecular mass, atomic weight, atomic volume, molecular volume. Okay. After that, you studied the molecular mass, the mole concept, how to calculate that. Okay. And the last one is percentage composition. These things we studied in unit 1. So the next one is, that is unit 2. So what is that unit 2? Atomic structure. So in the first class we studied about atoms. Matter is classified, and matter is consist of in smallest indivisible particle called as atom. So in this class we are going to study about the particular atom, what it contains, what is there in that, why it is called as atom, whether atom is the smallest particle or not, or anything else is present inside that atom, how they are arranged, everything is studied in this atoms. Okay, so students, this atomic theory, this the atomic structure is studied by so many scientists, starting from what? John Dalton. Okay, John Dalton, he suggested atomic theory, explained successfully how the atomic structure works. Okay, so in that atomic structure, so many scientists worked on it, and finally they came to know. So atom is not a smallest particle. Of course, it is the smallest particle. It is indivisible particle. Then, so it consists of another subatomic particles like protons, neutrons, and electrons. Okay, so listen. Atom is the smallest indivisible particle of the matter. Okay, even though atom further consists of subatomic particles named protons, neutrons, and electron. So the atom consists of a subatomic particle named as proton, neutron, and electron. Okay, next. Protons and neutrons are present inside the nucleus, so they are called as nucleons. So they are called as what? Nucleons. Next, the electrons are revolving around the nucleus in different energy shapes. So this is all about the atom, students. Atomic structure. So in that so many theories are there. In that so many theories, the atomic structure came to know the basically what is that atom means. The atom is the smallest indivisible particle of the matter. Of course, it cannot be indivisible further. Even though it consists of what? The subatomic particles like protons, neutrons, and electrons. Okay. So one atom is there, as I told you, for sodium. Assume atomic number is 11. Atomic mass is 23. Here, number of proton is 11, number of electron is 11, number of neutron is 12. Okay, if you write the electronic configuration, students, you get 1s2, 2s2, 2p6, 3s1. Okay, so then atom is the smallest indivisible particle. If sodium atom is there, it cannot be divided into protons, neutrons, and electrons. Together, they are called as what? Atoms. They are indivisible, but they are classified into protons, neutrons, and electrons based on their position in the atom, based on their nature, based on their structure, mass, and also the charge. Okay, and students, as I told you, it is the smallest indivisible particle. At the same time, they consist of proton, neutron, and electron. And the protons and neutrons are present inside the nucleus, and electrons are revolving around the nucleus in different energies. So I will write the simple sketch of the atom. So listen, this is the nucleus. Okay, this is the nucleus with what are present here? Protons and neutrons are present inside the nucleus. Here, how many protons are there? Here, 11 protons are there, or neutrons are there. So, protons 11, neutrons 12. This is nucleus. Next, the electrons are revolving around the nucleus in different energy shells. So first one, as I told you, 1s is 1 shell, 2s, next to 3s. So this is 2 electrons, that is 1s shell. Next this one, 2s and 3. 2s, 2p orbital, this one is, okay, this is 1s orbital, and this one is 3s orbital. Okay, this is a typical structure of what? A atom. So atom consists of the subatomic particles, protons, neutrons, and electrons. Protons and neutrons are present inside the nucleus, so they are called as nucleons, and these electrons are revolving around the nucleus in a different energy shells. So students, the mass of the element is directly depends upon what? The density of the nucleus. So the mass, the atomic mass means what? Number of protons plus number of neutrons. So only nucleus gives the atomic mass of the individual atom. So the mass of the atom is defined by what? The number of protons and neutrons. Only nucleus is present in the gives the mass of the atom. Gives a weight to the atom. But the electrons, they have charge, but they don't have mass. They have a mass, students. If we compare the relative mass with respect to charge by size ratio, it will approximately 0.000054. So that's why we didn't, so we get the very less value, so it is taken approximately 0. So the mass of the electron is negligible. The mass of the protons and neutrons are taken as 1. Okay, so this is all about the atomic structure, the subatomic particles, and how the atoms is classified. So next we will discuss about, students, how electron, proton, neutron, who discovered the subatomic particles and what are their charges and mass. Okay. Proton and electron. So first, scientist name. Who discovered this? Proton, neutron and electron. So this is students, proton was discovered by Goldstein. Proton was discovered by James Chadwick. James Chadwick. And electron is discovered by J.J. Thomson. Okay, students. Proton is discovered by Goldstein. Neutron is discovered by. Sorry, I wrote this spelling wrong. Neutron is discovered by James Chadwick, and electron is discovered by J.J. Thomson. So, year of discovery. When they discovered. So, proton is discovered in the year 1836. Okay. Neutron is in the year 1932. And electron is in the year 1897. So, first, Goldstein discovered this proton in the year 1836. Later, J.J. Thomson discovered. In that, not only proton is there, electron is also there. That is 1897. So next, neutron is discovered by James Chadwick in 1932. So students, for this discovery of electron, proton, and neutron, so many structures they assume, so many experiments they conduct. How? So listen, I will give one example. So this J.J. Thomson first considered what? The protons are there because protons are already discovered at that time, and he assumed electron also there. There is no possibility of presence of only positive electron. Okay, sorry, positive atom. There may be a negative atom also. So at the year 1897 already this proton was discovered. So he came to know in an atom protons are there, electrons are there. So he started assuming the protons and electrons are in what? Watermelon structure. So watermelon structure means atom may be in the form of a watermelon. So that means what? So the red part of the watermelon is nothing but the positive charges. The white black color sits inside that watermelon is called as what? Electrons. He assumed that the atom must be or may be in the form of a watermelon. The red color part is called as protons, and the seeds inside that, the black color seeds inside that red color fruit is called as electrons. So he fails to explain the stability of the atoms because there is no proper arrangement of the protons and electrons. We cannot explain the stability of the atom, why it is stable. If only protons are there, electrons are there, then what about the neutrons? So he doesn't know only protons are there, neutrons are there, or any some other particles are there. Still he didn't know anything. Okay, so he already proton discovered and he thought electron may be present. So he discovered electron also present in the subatomic particle, but he fails to explain the structure of the atom because he assumed it is in the watermelon form. But the stability of this watermelon form is not that much stable. So this theory is disqualified. Okay. So the next one. After so many years, in 1932, the James Chadwick, along with the proton, electron, neutron is also present in the atom he discovered by bombarding with the beryllium atom with the alpha wave. Okay, alpha scattering it. So he did beryllium is bombarded with alpha, then it converted into boron with the liberation of or elimination of one neutron. He said then neutron is also present inside the atom. Okay, so the next one is mass of proton, neutron and electron. So the mass of proton is 1.67 into 10 to the power of minus 27 kg. Okay. So mass of neutron also 1.675 into 10 to the power of minus 27 kg. Okay. So mass of electron is 9.107 into 10 to the power of minus 31 18. So students, see the difference here. Here 27 is there, here 31 is there. Minus value means it is very least value. Okay. Next, charge you consider. This is plus 1.607 into 10 to the power of minus 19 coulomb. This is 0 to 0 charge. This is minus 1.607 into 10 to the power of minus 19 coulomb. So protons and electrons have the same charge, but proton is positive charge, electron is negative charge. This is neutral charge. So if you want to take relative charge, students, relative mass is equal to 1, 0. Okay? And if you want to take relative charge, so this is mass. Mass of proton is 1, mass of neutron is 1, mass of electron is 0. That's why students, if you write here Na1123 means 23 gram we will take, because mass of proton is 1, mass of neutron is also 1. Correct? And here relative charge. Here proton 1, that is plus 1. This is 0. This is minus 1. That is the relative charge of the. So this is proton, neutron, and electron. So these are all the subatomic particles present inside the atom. Okay. This is proton. This is neutron. This one is electron. And this is very important thing, students. You have to remember this. Who discovered, in which year, what is their mass and what is their charge, what is the relative mass and the relative charge. Okay. So the next one is very important thing. After discovery of the atoms, we came to know orbit and orbital. Okay. So the next one is orbit and orbital. Okay, students, orbital is there. So orbit means it is, right, orbit it is a well-defined circular path around the nucleus where the electrons present. That is called as what? Orbit. Okay, the electrons revolve. Not present, electron revolve. So orbit is a well-defined circular path around the nucleus where the electrons are revolved. For example, this is the nucleus. As I told you, this is called as what? Orbit. 1, 2, 3. So this is the orbit. The main thing is, students, so listen, the orbits are called as shells denoted by K, L, M, N and numbered by 1, 2, 3, 4. Okay, students. So the orbits are called as shells. So here, this is, they said, the nucleus, the next shell is K shell, this is L shell, this is M shell. So K, L, M, N shell is there. So and it is denoted by K, L, M, N shell and numbered by 1, 2, 3, 4. For example, if you write as I told you, atomic number of sodium is 11. We write it as 1s2 2s2, 2p6, 3s1. Correct? Here we number one cell, K shell as 1, L shell as 2, next M shell as 3. Okay, understood? Here K element shell is there, numbered as 1, 2, 3, 4. Okay, students, here what happens? The numbering is taken here for the different energy shells and the name is taken as K element shell. Okay, so this is where the electrons revolving around the shell. So the total number of electrons, one thing is total number of electrons, and I will write it again. Here I will write. So here to write K shell value is 1, L shell value is 2, M shell value is 3, N shell value is 4. Remember that. So next, total number of electron present in the shell is equal to 2n square. Okay, so students, number of electron in K shell, that is 2 into 1 square, because K is equal to 1 here. That is how much? 2 into 1, that is 2 electrons. Next, number of electrons in L shell, 2 into 2 square. Why? Because L is equal to 2. 2 into 4, that is equal to 8 electrons. Similarly, number of electrons in M shell, how much? 2 into 3 square, that is 2 into 9, that is 18 electrons. Okay, so the last one is there, and right here, number of electrons in N shell, that is 2 into 4 square, 2 into 16, that is 32. So students, for example, I will take atomic number 40. Okay, so listen, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d. Remember this exercise. So listen, 1s addition, K shell is there, maximum electron is how much? 2. This is 2. Second, L shell, maximum, that is 2 value, that is equal to how much? 8. Here, the number of electron is 6 plus 2, 8. For third, it is 18. Listen, you consider this. This is 18. So another if you write means you may take this and read it and put 14 students, then it will this much, that is 32, right here 32, 18, 8, 2. So this is the maximum number of electrons can be fit in the orbits. Okay, so here the formula is equal to what? 2n square. N is equal to what? The K element shell. But here now we are not taking K element shell, we are numbering. We are taking the number of the respective shell. For K, N is equal to 1. We are substituting here, we will get 2 electrons. Once we substitute the value of the respective shell here, we will get the maximum number of electron can accommodate in that orbit. Okay, so this is all about the orbit. So orbital is there. So what is the orbital means? It is the three-dimensional representation of the electron in which it is arranged in the space. Okay, it is the three-dimensional arrangement of the electron around the nucleus. So this is all about the orbit and orbital. So in the tomorrow's class, I will discuss about the orbital.